Okay, so we're going to talk about some specific problems from the Gazzetta Matematica for geometry problems. So specifically from like 8th grade, 9th grade problems of the Mathematical Gazette. So the first problem we're going to talk about is consider the rectangle ABCD with CD equaling A. Extend CD so that C with point E such that CE is equal to BC equals B. The perpendicular from D to AE intersects side AB and F. Compute the distance DF. So the best way to start the problem is to do a coordinate proof. And the coordinate proof, we're gonna draw a rectangle ABCD. Set D at the origin. We're gonna have A at since the height is B, we have BC equaling B. We'll have AB 0, comma B. We'll extend. We also have BC. We also have CD equaling A. So you have CB A0. We will extend that CE. So since you have C equaling A0, you'll have E equals A plus B 0, and B is equal to A comma B as the other vertex of the rectangle. And what we're trying to do is compute that distance of DF. And so what we can start doing is we can start by finding the equation of the line AE, and since we're given the y-intercept and the x-intercept, we can actually use that to find the equation x over the x-intercept plus y over the y-intercept equals 1 to find the equation of the line. And if we put this in slope-intercept form, what you'll find is that you'll find the slope. You'll have minus b over a plus b x plus b. And so when you find the slope, you have, we're going to call the slope m of AE. When you find the slope of AE, you'll find that it is minus b over a plus b. So what you could use with this information is to find the slope of line DF. So if since the perpendicular to AE, you can just say opposite reciprocal to say that it is a plus b over b. And since this passes through the origin, which we set D to be the origin, we can say that the equation is y equals a plus b over bx. Now, why do we need this equation? Why are we finding the equation? Because we're trying to find the coordinates of point F. So we know the y coordinate of point F since it's on the line on line segment AB, so we know it's b. So we can just plug b into the equation to say x is equal to b squared over a plus b. So therefore F would have the coordinates of b squared over a plus b, comma b. So setting D at the origin makes it easier to compute the distance, since the distance, you just use the distance formula to find. So now all you need to do is just say x sub 2, the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So you plug in b squared over a plus b and b. And with D being the origin, and you get b to the fourth over a plus b squared plus b squared. And the way you can simplify it, just take out b over a plus b, and you'll end up with b squared plus a plus b quantity squared. So that's so the distance DF is b over a plus b times the square root of b squared plus a plus b quantity squared. All right, so before I start going into the second problem, let's actually go over a specific theorem, which is Stewart's theorem and Pappus's median theorem. So here is actually Stewart's theorem. So for any triangle that you have A from A to side BC, if you have a point D on BC and you draw a line from A to D, then for any arbitrary triangle, then you have AD squared times BC equaling AB squared times DC plus AC squared times BD minus BD times DC times BC. So what about if AD was specifically a median? Then that means that BD would be congruent to DC. So for that specific case, if we let BC equal A, if we let AB equal C, and if we let AC equal B, we can say that the median of A squared would be B squared plus C squared over 2 minus A squared over 4, because you're just plugging in these values into Stewart's formula and simplifying. So that's just the median theorem. So what we need this theorem to solve the next problem, which is consider a triangle ABC and the midpoints of segments BC, AC, and AB denoted by M, N, and P respectively, prove that if Bn squared plus Bn squared plus Cp squared is equal to BC squared plus AM squared, then the triangle must be right. So one thing we can do is, for this kind of thing, we can say what is Bn, what is Cp, what is BC, what is AM. We know that Bn and Cp are medians, specifically that Bn is the median of B, that Cp is the median of C, and that AM is the median of A. So specifically you know that, and you also know that BC is equal to A, so you can just plug that in. Now, we use Stewart's formula, we just simply substitute it here. So for this one, you'd say a squared plus c squared over 2 minus b squared over 4 plus a squared plus b squared over 2 minus c squared over 4 is equal to a squared plus b squared plus c squared over 2 minus a squared over 4. So if you just multiply both sides by 4 and you simplify the equation, just combining like terms, you would end up with b squared plus c squared equals a squared. That's the Pythagorean theorem. And because of the converse of the Pythagorean theorem, you know that the triangle must be right.
So, Montu, can I stop for a second? So I have to tell you, this is a wonderful story. So Montu did a poster for this. The poster, I believe, is in the next room. Did you find it?
Yes, room 484.
Yeah. So and then I took the PDF, the poster, and uploaded it on Facebook because I love it. And then I got comments from Romania. They looked at the poster and they go like, "Oh, we didn't do it like this." So what happened? We're talking about this problem. They changed the curriculum in the last years, and this problem, I believe it was intended to be solved with vectors. Did we ever talk about that? No. We have no idea. So the idea is that you can solve it actually like in the Calc 3. You take vectors and you solve it vectorially, which I had no idea that, but the solution is kind of about the same. I think this is shorter and more direct and somehow more natural. So, but I just wanted to tell you that we are actually, because of this difference of curriculum between Europe and us, sometimes we're coming up with all sorts of ideas, which is interesting. Good one. Sorry for interruption.
That's okay. And for the last one, we're going to say just that for any triangle ABC in which the following relations hold true, cosine of A plus cosine B equals 1, and sine of B equals sine of C equals 2 times sine of A, the triangle must be equilateral. So this requires a more trigonometric approach. Just by understanding that the triangle is a triangle, you can just add up the angles to say angle A plus B plus C equals 180. And what you can do is, since you only have two equations with 3 unknowns, you can find the value for C in terms of A and B. That C is 180 degrees minus A plus B. And you can substitute that in the second equation and say that sine of B plus sine of 180 degrees minus A plus B equals 2 times sine of A. So if you know about your trigonometric plane and the fact that sine of 180 degrees minus any angle will be the same thing as the sine of that angle, you have sine of B plus sine of A plus B equaling 2 times sine of A. And if you just rearrange the terms, we can just say 2 times sine of A minus sine of B equals sine of A plus B. So now we can use the addition theorem, because you're adding two angles in the same operation, to say that it is sine of A times cosine B plus cosine A times sine of B. And we can group these factors together and to say sine of A times 2 times cosine B is equal to sine of B times 1 plus cosine A. Now, where are we going with this? Well, let's look at the first equation. We know that cosine A plus cosine B equals 1. If we added 1 to both sides, you'd have 1 plus cosine A plus cosine B equaling 2. Now, all you need to do is bring cosine B to the other side. You have 1 plus cosine A is equal to 2 times, well, 2 minus, 1 plus cosine A equals 2 minus cosine B. Now, notice that 1 plus cosine A and 2 minus cosine B are equal, and the fact that they're on both sides of the equation. And since the only way that 1 plus cosine A or 2 minus cosine B could ever equal 0 is if A would be 180 degrees, which cannot happen because this is a triangle. So we can cancel the terms out and simplify to say that sine of A is equal to sine of B. If we solve this equation for A, well, you'd have A equals B, or A is equal to 180 degrees minus B. Well, if you plugged in A equals 180 degrees minus B into the equation of cosine A plus cosine B equals 1, well, then you get cosine of 180 degrees minus B plus cosine B equals 1, and cosine of 180 degrees minus B would be the same thing as negative cosine of B. and that is for anything on the that is for any angle, and because of that, negative cosine b plus cosine b equals 0. 0 does not equal 1, so you can just reject that case and say that a is equal to b. If a is equal to b, you can substitute that in the first equation to say cosine of a plus cosine a equals 1, and 2 times cosine a equals 1. So cosine a would be equal to half, and a equals 1. Well, a will equal 60 degrees. If that's the case, then b will also equal 60 degrees, and then c must also equal 60 degrees. If all the angles of the triangle are 60 degrees, then the triangle is equilateral. Thank you.
Thank you very much. Questions? Then I have a couple of other remarks. As you can see in this particular project, there was an analytic solution, there was a synthetic solution, and there was a trigonometric solution. Right? I like very much that catch with the factor that was like 2 minus cosine p. That's because there was one of the derivations of the system. That was a good catch. I wouldn't have seen it. I don't know how you saw it, but most likely you were like looking at all of that. That was beautiful. In that stuff. Now let me tell you Montu's background. So he already did 2 posters. The oldest one is right there in the back, on the wall. The second one is the content is right here. Montu spoke 3 times in the students' colloquium. He spoke once at the MA conference, right? Did I miss anything?
Oh no, you're right.
Okay, so it's a fantastic record. Thank you very much. So now we're gonna change a little bit the